Whoa. Hello. So, what I'm going to do today is a physics simulator. So, on the new version, I just added some demos to the distribution. If you download it from my website, the standard distribution, there's a template directory, and this has templates. So we're going to start with, I'm going to copy all, this is the standard game template. It has a draw it, an animate task, init, cleanup, song, and then the game main loop. So this is just a template. Makes it a lot quicker to get started. So then we're going to go to the ordinary differential equation. Today we're going to do physics. So we're going to copy this into the So this, we want to replace the init and cleanup with the new init and cleanup. And we're looking good. Okay, so there's a base class for masses and a base class for springs. So you know what we're going to do? First of all, oh, my dog wants in the room. No. Okay. We're going to make, when you press the P key, it places. We're going to, oh, I forgot, we're making masses and springs. Place mass, how about that? So, we're going to make a menu entry. Oh, this is not play. This is, what would you call it? Edit. Something like that. So, you might not be familiar with how this menu works. Okay, so, place mass. So I think, oh, the first one is, what is that, up, down? This is where you put the P. Okay, let's just see if my dog wants in the room. No! Okay. Let's see if it compiles. Yeah, it does. Okay. Okay, so we want to place a mask, place a mass. Okay, let's go ahead. I don't know. I try to standardize, but oh well. This is a my mass star dbm equals calic size of my mass. Okay, so you know what we're going to do? Let me just show you what a mass looks like. What it has is a mass. Whoops. A mass has an XYZ, a derivative XYZ, and so my dog's scratching my bed. Anyway, these pointers are important for... Okay, so here's the deal. The ODE structure has an array for the state, and that is 6 numbers for each mass. And since masses can be created or destroyed, the size of the state changes. The individual masses, these pointers point to the array in the ODE. I should write that down. I should write that down. So there's a Q for these masses. Here's the state, and here's the Q head of the Q head of the springs. I'm going to say Control L, link, man page. I'm going to say that should clarify. And D state. Oh, is there a D state? I don't even know if there is a D state. Yeah, of course there is. I didn't know that. Point. I am annoyed. Okay, what the hell? Okay. We're in no rush, are we? Yeah, we are. So when you call the derivative, when it calls the derivative callback, it's going to require us to return the derivative in the D state. Okay. So good enough. So I just wanted to show that. So that means the value we modify is here, and input pointer IPX. This is actually a very complicated. Let me just show you what the first approximation of this is. The input pointer is the mouse, and then we say Q insert, and okay, so that should place, whenever I press the P key, it should place a mask. A mass. I did not. Oh, well, we're not drawing it. We have to draw it, of course. So that means we have to. I'm just going to copy this loop into the draw it, and we don't need 2 masses. Now we say, you know what I'm going to do? Control Shift F. Oops, that's not what I'm going to do. Control F. Temp M1. Temp M. Just a perfectionist. Rename local variable. Oh, okay. Now I say GR circle. Radius, let's say radius 3. Okay. Now if I hit P, okay, we're off by 8, and the reason for that is this is world coordinates. So for long story short, we want to say minus minus fs pixel left minus fs pixel top. But it gets a little bit trickier because there's a scroll X and a scroll Y. Okay, so P. Okay, now if I can grab scroll, and then if I do P, it's wrong. Okay, so did you know that there's a grab scroll that pans? Long story short, we want to say minus fs scroll X minus fs scroll Y. I go place. I'm going to grab scroll and place again. Okay, beautiful. Beautiful. It's beautiful. Okay, so what if we make the left button do it? Do we want to do that? No. Oh, well, what? I don't know. Okay, so now we want, now here's where the physics starts. What if we make these gravitational? How about that? So, you know, it's kind of a pity that I didn't use, well, long story short, there's a data type. If you type F1 and you go to data types, there's a data type CD3. This is a double, or, oh no, it's a three-dimensional. I forgot what the D was. Anyway, it's floats. What I'm going to do here is just put this in. I just want to keep it handy. So what we say is CD3 P. And then we're looping through, we want gravity. Okay. So what do? We say we want to subtract the two vectors, the two masses, subtract the two position vectors. Okay, so this is the derivative. Okay, let's just do it. Long story short, let's do it. Okay, so D sub 3, so D1, D2 diff. Okay. So I like to do, so the state, I guess, now the state is passed in, and the derivative of the state is passed in, but we're going to use pointers. We want the to state, I think this is what we want. So and then we put it into P. So we say address P. We don't have operators and C++ data types. That's kind of a pity. Okay, now let's go ahead and make F64D D equals D3 norm address P. Now we could say unit. You want to be wasteful, or we can say we want to turn p into a unit vector. So that means let's divide by the div equal quotient scalar. Okay, so we say d3 div equal. Now, if the norm is not 0, otherwise all bets are off. Div equal address bd. Okay, so we made it into a unit vector. Now, let's go ahead and you want to do it in one step? Okay. Sigh. Okay. Masses. Do the masses have a mass, or is that... The masses do indeed have a mass. Okay. So we want to set the mass. We could use real numbers, or we could use video game numbers. 1 kilogram. We're not going to use the gravitational constant. I don't feel like it. We could, but we're not. So now we say let's we're going to multiply. I presume it's the same format. Gravitational constant, do we want to make one? Might as well. And we'll say 1.0. What's this going to be? Any clue? So this is 1 pixel per second squared. It's in units of pixels. So gravitational constant times temp m1 mass into divided by d times d. Okay, so we just calculated gravitational constant, and now we want to add. Okay, so I think it divides by the mass when it I don't remember. Control D, atom directory, math ODE, Control F, mass. Control Shift, Control F, insert. Okay, look at that. Look at that. Okay, so when we supply the derivative, and then it divides the force. We supply the force, and it automatically divides by the mass. We have masses. Okay, so it's doing a lot of work. So we supply the force. So let's add 1 plus 2 into sum. Add equal. Let's do add equal. Sum into sum d. Why are some of these one direction and some the other? Is that my imagination? It's my imagination. I could swear we went 1, 2, we did go 1, 2, 3. You think I should rearrange all those to me? Why is sum 1, 2, 3 but this one like that. Shit. I might have to change that. Okay. What? See what I'm talking about? This is doing 1, 2, and then some, but this is doing, one's going left to right. Okay. Anyway, add equal. Add equal. Son of a bitch. How could I fuck that up? Okay. So we say temp D state okay. So this should, I'm not paying attention. What if I made it repulsive? Well, let's just guess. Oh, let's try it. So it's 2, it's pointing to 2. So if it's pointing to 2 and we're adding, this is repulsive. We want to subtract. Am I a genius? We'll find out. Okay, so now we have, let's go ahead and give them a velocity. Otherwise they'll slam into each other, and we don't want that. Is it D? Oops. DXD, it's big. Okay. Let's just do that. Okay. How about random? Let's make some viscosity. Otherwise, no, better not. Okay, here we go. Ready? Here we go. Okay, they don't appear to have much gravity. Let's crank it up 100. Okay, so it appears to be working. We just have to crank it up. Okay, so the time scale. Okay, here's the deal. Here is the deal. We have a limitation on acceleration that causes it to stop. It would be a singularity. Okay, so let's go ahead and draw the circle based on the mass. So we want let's do it based on the mass. Let's make the mass log or ln, or no, we want exp rand. That's 0 to 1 plus 1. about 10, 5, 3, what? Say 3 times? Say 4 times around. Okay. Okay, that's a little bit crazy. Okay. The time, why is the time so fast? We can slow down time, I think. That doesn't make any sense. We need to give them a bigger random velocity, I guess. This is space, so what we should be doing is black and white. This doesn't matter. So when we draw it, we want to say, what if yellow? I like yellow. You want to fill it in? Let's go ahead and fill it in. Flood fill. So I can grab it and scroll. Okay, I'm happy. You know what I'm going to do? I'm going to break the entire API and fix it. Isn't that crazy? No, that's... It has to be perfect because that's how we operate. So it's going to be perfect. I don't know. What the hell was I thinking? I don't know. I don't know what the hell I was thinking. Okay. So next time you see me, that'll be different.